Hi, I want to show you a working circuit, state part only, no output. Um, this is the circuit that I'm wiring up. It's, the circuit from the slides from Harris and Harris book that you're supposed to do for your lab in EE275. And basically, there are four states. Um, if the input TA and TB are both 0, then the circuit's just going to circulate from state 0 to state 1 to state 2 and state 3 and back to state 0 again. Okay? Now, as far as the clock is concerned, I'm reminded once again something that I knew from before, namely that you cannot just use a switch for a clock because it bounces, and debouncing a switch can be a pain. So instead, I'm using our function generator here, channel 1. As you can see, I'm using, let's see, a square wave, a 1 hertz frequency, amplitude of 5 volts peak to peak, and a DC offset of 2.5 volts. Okay, a 50% duty cycle, 0 phase. So it's just a square wave that looks like the picture there. Okay, and I connect the ground of the function generator to the ground of the power supply there. Okay, so that we'll have the same ground reference. And for a while there, my ground wire came out of the board, and the thing didn't work, and I wondered why. But anyway, I stuck the ground wire back in, and it's fine. So it takes a tremendous amount of concentration to do all the wiring right, and it took a long time to get that right, even though seemingly it's a simple circuit. But it isn't as simple as it looks when you have to actually do the wiring. And I try to wire as neatly as I could, but there are people who do better wiring than I can. But at least I try not to have wires cross over, above a chip, so that if I have to remove a chip, it'll be easy. And in fact, I did have to remove chips because by not realizing it, I switched the wiring of chip number 1 and chip number 2. So my chip number 1 is actually the 7474 D flip-flop chip, unlike in the diagram that I showed you. In the diagram I showed you, the inverter chip was the first chip. But since I miswired, I had to switch chips physically, and everything's fine. Okay, so now that works. To test to see that it works, well, I first set TA, which is that switch, to 0, which is down, and TB, which is that switch, to 0, which is down. Okay, that switch was my clock, but I'm not using it because it bounces it. It bounces. Okay, so with TA and TB down, okay, the state should cycle 0, 1, 2, 3, 0, 1, 2, 3, like that, and as you can see, it does. Let's see, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. See? And if I switch TA up, if I switch TA up, as you can see from this diagram, let's see. Okay, if TA, yes, if I switch TA up, yes, then as you can see, we should be stuck in state S0. Okay? Whereas if I switch TB up, we should be stuck in state S2. Okay, so let's switch TA up. As you can see, we are indeed stuck in state 0. The light are not going on anymore. Okay, if I switch TA back to 0 again, then the states will start cycling again. See, 1, 2, 3, 0. See, now if I switch TB up, I will be stuck in state 2. See, let's look at this diagram again. See, if I switch TB up, then once I get to state 2, I'll be stuck right there. So let's do it. One, two, stuck. To get out of that, I have to switch TB back down. And now I'm cycling again, see? And if I switch both TA and TB up, then I'll be stuck at either state 0 or state 2, whichever one I reach first. Okay. So, all right. And that is actually my reset right there. If I put it down, then I will asynchronously reset the state. Okay, let's take a look. See? And when I switch that thing back up, I'll be recycling 0, 1, 2, 3 again. 1, 2, 3, 0. 1, 2, 3, 0. Okay, that's it.